You ever watch a big log in a campfire just burn away? You start with this heavy piece of wood, and after a while, all that's left is this tiny little pile of ash. It feels like magic, right? Like stuff just vanished into thin air? Well, what if I told you it's all just a really clever illusion? Today, we're going to uncover that secret.
I mean, seriously, think about it. It's the ultimate disappearing act. You've got something solid, something heavy, and poof, it's practically gone. It's one of those things that seems like it should be impossible. So, did that log really just disappear?
So, that's the big question, isn't it? Where does all that matter actually go? Let's pull back the curtain on this mystery of vanishing stuff.
Here's the secret. It's a trick. It really looks like matter is being destroyed, whether it's burning, fizzing away, or rusting into dust. But the truth, not a single atom is actually gone. It's all still there. It's just changed its disguise. And this all leads us to one of the most fundamental, unbreakable rules in all of science. It's called the law of conservation of mass. And honestly, this is the key that unlocks the entire mystery.
Just let that sink in for a second. Matter can't be created or destroyed. It means that the very same atoms that are in you right now could have once been part of a dinosaur or a distant star. The universe isn't making new stuff or losing the old stuff, it's just constantly recycling and rearranging these same ingredients.
Okay, so to really nail this down, we have to be super clear on what we mean by mass. Don't worry, it's not complicated. It's just the total amount of stuff that makes up an object. Think of it like a head count of all the atoms inside it, which we usually measure in grams.
And this is a really important point. So often people mix up mass and weight. Your mass, the actual amount of you, is the same whether you're standing on Earth or bouncing on the moon. Your weight, on the other hand, is just gravity's pull on you, so that changes depending on where you are. This law, this unbreakable rule, is all about mass, the thing that stays constant.
All right, so this is probably the question popping into your head right now, right? If this law says mass can't change, why do our own eyes tell us a totally different story when we watch that log burn down to practically nothing? Well, the answer's kind of hiding in plain sight, or more accurately, it's invisible. All that missing mass from the burning log didn't just vanish. Nope, it transformed into things we can't easily see, like smoke and invisible gases like carbon dioxide and water vapor. And all of that stuff, which has mass, just floated away into the air.
Okay, so how does this whole transformation thing actually work? For that, we need to zoom way in and look at the universe's ultimate building blocks, atoms.
You know, probably the best way to picture this is with Lego bricks. Imagine you build a Lego car. A chemical reaction is like taking that car completely apart. You don't lose any of the bricks, right? You just use those exact same pieces to build something new, like maybe an airplane this time. That's all atoms are doing, breaking their old connections and snapping together in new ways.
You want to see this in action? Let's think about that classic kitchen experiment, mixing baking soda and vinegar. It's a perfect, everyday example of this whole principle.
So you mix them together and you get that awesome, satisfying fizz. You see all those bubbles rising up, and then they're gone. It totally seems like you're losing mass with every single bubble that pops. But are you, really?
No way, not a single bit. Those bubbles are actually a whole new substance, carbon dioxide gas. And that gas has mass. If you could somehow trap all those bubbles, say in a balloon placed over the bottle, you'd prove it. The total weight of everything before and after would be exactly the same. No mass was lost, it just turned into a gas we can't see. So this is a pretty cool idea, but why is it so important? I mean, why is this considered one of the absolute foundations of science? What does it let us do? Well, for starters, it's basically the official rulebook for all of chemistry. This law says that every single chemical recipe, what scientists call an equation, has to be perfectly balanced. You have to account for every single atom going in and coming out. It's kind of like balancing a checkbook. Let's take the recipe for making water. You start with hydrogen and oxygen. If you look at that first equation, it's unbalanced. An oxygen atom just magically disappears, which we now know is impossible. The law forces us to fix the recipe, to make sure the number of hydrogen and oxygen atoms is the same on both sides. Now, the books are balanced.
And this goes way beyond just writing equations. This law is everything. It's what allows scientists to predict what will happen in a reaction, it helps them design safe experiments, and it gives us this really profound understanding that the universe is a closed system. All the pieces are here, and they're all accounted for. Always.
So, what are the big things to remember here? Let's just break it down. 1. Matter is permanent. You can't make it from nothing, and you can't destroy it. 2. Because of that, the total mass inside a sealed container will never, ever change. And 3. All those amazing, sometimes explosive chemical reactions, they're really just atoms doing a little dance and finding new partners.
So, the next time you watch a candle burn down or drop an acid tablet into water, remember what you're really seeing. It's not a disappearing act. You're watching a beautiful, predictable, orderly rearrangement of the very same building blocks that make up everything in the universe. It's not magic at all. It's just chemistry.